Hello everyone and welcome to another video. Today we're gonna continue with our hello programming language. So in the previous video we were actually starting to define the visitor that is going to visit every node in our abstract syntax tree recursively. So yeah, we only did the header file, so let's implement them as well. So I'm just going to copy these and I'm going to put it in a visitor.c file. Put it here and I'm going to include the header file. So just to recap, I always like to do this. We wrote a lexer that turns our source code, this, into tokens, and it gives the parser the tokens, and the parser turns the tokens into an abstract syntax tree, which we have defined here, which is basically just a recursive tree. And then our visitor is going to recursively visit all the nodes in that tree and perform operations based on what kind of node it's encountering. And yeah, so that's what we're going to do today. We're going to start writing that visit code. And this will enable us to actually make our source code do something. So yeah. I'm going to put some curly braces here. I know someone in the comments section told me to use the dot to like repeat motions in Vim, but I never got that to work. Oh, there we go. Kind of worked. I don't know. So, as I said in the last video, or the previous video, the visitor visit function is like the main entry point for the visitor. So the node it's going to take in here is actually the root node that we have in our main.c file here, this one. Just to be clear. So the root or the main visit function here is going to have a switch statement, and we're going to switch on the node type. And based on what that type is, we're going to jump to the appropriate function for that node. So if we encounter a variable, we're going to call this function. And if we encounter a string, we're going to call this function. Yeah, you know what I mean. So case, let's start with the variable definition. Ist variable definition, return visitor visit variable definition node break, and then we're gonna have a case ist variable return visitor visit variable node break, and then we're gonna have a case ist function call return visitor visit function call node break, case ist string return visitor visit string node break, whoops, break, case ist compound return visitor visit compound node break. Right, and if we're not ending up in any of these, then we have an uncaught statement that we aren't handling. So I'm just going to print an error here. Printf uncaught statement of type. I'm going to print the type, node type, and I'm just going to return void or a null pointer for now. Actually, let's just exit. We're never gonna reach the return statement, but I like to have a return statement there either way. Okay, cool. So let's start work on the compound function, because that is the node type that we're gonna encounter first, because the root node is the whole source code, which is a compound statement. So let's do that first. So we have if we look in our ast.h, we have the compound attributes here. So we have the compound size. So we want to loop through all the compound children and visit them. So like this, for int I is equal to 0 if I is less than node compound size I++. And then we want to do visitor visit node compound, what do we call it? Compound value I. I'm going to move my camera a little bit. Okay, so we're iterating through the children, the size, and we're calling this visit method on every children, basically. And that's it. Now, I always like to return something from these, you know. So we're going to implement another type of AST type. So in our ast.h, I'm also going to add another one here called AST_NOOP, which is short for no operation. So when we're done here, I'm just going to return init AST_NOOP. We can actually do that here as well. As I said before, we're never gonna reach this return statement there, but I don't know, it just looks nice. Okay, so now I expect this loop to be looped twice, so I'm gonna print I here, because we have two children in our compound node, remember? So I just want to see if that works. So, because in our source code we have two statements. We have the variable definition and we have the function call statement. So if we go into our main, we're going to include our visitor. So include visit.h, visitor.h, and we're just going to call visit root, our root node. So I expect it to print 0 and 1 because we have two statements. It should be visitor visit. And we also have some warnings. We need to include some stuff. It doesn't know what printf is because we need to include stdio.h. I'm gonna recompile everything, so make clean, make. Cool, so now if we run this, we're getting 0 and 1, as I expected, but we're also getting a segmentation fault for some reason. So I'm just gonna see why that is. So I'm gonna run valgrind. Visitor.c line 7, switch node type. Okay, so we're getting a all right, so we're getting a void or a null pointer here. So we're just going to do if not node return what are we going to return? Return init AST_NOOP. I think that will solve it. No? Line 10, switch node type. That's weird. If node is equal to void curl. That's very strange. Visit compound line 4. Oh, it might actually be narrowing the parsing thing here. So when we're parsing compounds, where are we? Parse statements, parse function call, parse variable. Right. So what we have to do here is also, we don't want to add any statements to our compound value list if they are really real statements. So what I'm going to do here is if AST statement parse statement, and if we don't encounter anything in this switch here in our parse statement, I'm going to return init AST no operation. Let's also do that in our parse expression actually. So if we encounter something that we don't currently recognize, I'm just going to return init AST no operation. Right? Recompile. And we're getting an uncaught statement. And this is because this is we're actually reaching a no operation. So let's just add it here. So case AST no operation. Let's just return the node if that happens. Okay. I think we don't need this anymore. Cool. There we go. Everything works as expected. So now I'm expecting us to visit a variable definition actually. So let's just print that here. Printf vardef. See if I'm right. No, we're not visiting a variable definition. Why is that? That's pretty strange. I'm gonna recompile everything. Okay, that's very weird. Are we visiting a variable? No. Are we visiting a function call? Yeah, we're visiting a function. So what? Let's just print the let's print all the node types that we're visiting actually. So printf type node type. Four, 2, and 5. Okay. 0, 1, 2, 3, 4. Okay, we're visiting a compound. Yeah, that's correct. 0, 1, 2. We're visiting a 2. 0, 1. Okay, that's very strange. I would really expect us to visit that one. So I think we're actually parsing a variable definition though, aren't we? Yeah, we are. And we're returning it. So maybe there is some problems here. Maybe we should do this a little bit differently in our parse statements. I'm going to do if parser current token type is equal to token ID. Then we're going to keep parsing statements. So we're getting a 4 and we're getting a 2. 0, 1, 2, 1, 2, 3, 4. That's really strange, actually. I don't understand why this is happening. We're parsing a statement. All right. So if it is an ID, very strange. Visitor to C. Node compound value I. Compound value size plus equal 1. So that will make it 1. Oh, I think we actually need to remove this, or what am I thinking? Compound value, compound size. No, sorry. Let's put it the way it was before. If AST statement, parser parse statement. I know that we're parsing variable definition, that's for sure. Init AST variable definition, return variable definition. So let's just print the, let's go back to the visitor, remove this print here. I'm gonna put a print in our visit variable definition just so that we can debug this. So visiting variable def, just to make sure we're not encountering that at the moment. So in our parse statements, I'm gonna print the type of this one. AST statement type. We're getting a 2 and a 5. Compound. Oh, I think we're losing this one. I think this one is probably the variable definition. Yeah, it is. So for some reason we're losing that one. Why are we losing that one? Compound value 0 is equal to AST statement. Okay. Oh, I know what the problem is. We need to do... okay, so after we have added the first statement to the list, we actually have to increase the compound size. So compound size plus equals 1. And we need to do this at another place as well. In our parse function call, when we parse the function arguments, the expressions here, we want to do that here as well. So parse function call, when we add the first expression to the list, we're going to do function call arguments size plus equals 1. Then I'm going to compile it and run. And there we go. We're visiting a variable definition. Awesome. Awesome. That's good. So we're visiting the stuff that we're expecting. We're expecting to visit a variable definition. And then we are expecting to visit a function call. So visit fcall. And we are. Awesome. So how do we perform the correct operations here? Well, first of all, when we are visiting the variable definition, we need somewhere to store that variable, right? So for now, I'm just gonna create like a global scope thing where we store memory stuff in. If you wanna be able to support like different scopes for function definitions and stuff, then that's not the way to go. But we're gonna do this now, and then maybe we'll improve it in the future. So now in our visitor.age, we're actually gonna define a state here to store stuff. So I'm actually gonna do type def struct visitor struct visitor t, and we're gonna have a list of AST nodes here. So AST t, let's just call this variable definitions, and then we're gonna have a size t variable definitions size. And now for every visit method, we want to add the visitor argument as the first argument. So we want to pass in the state. So visitor t visitor, visitor t visitor. I'm just going to copy this actually. And then we want to add those in here as well. Oh my god. Visit string. Cool. And then we also need to pass it in here when we call the function. So visitor. Visitor, 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 visitor. Awesome. And in our main method, when we call the main visit function, right, we're gonna pass in the visitor here as well, but we haven't defined the init methods. We're gonna do that. So visitor t init visitor. So I'm in the visitor.h file now. I'm defining the method to create the visitor. And we're going to go into the C file as well for the visitor, and we're going to define that init method. And we're just going to do visitor t visitor is equal to calloc1 size of struct visitor struct. And we're going to do visitor variable definitions is equal to calloc1 size of struct AST struct visitor variable definition size is equal to 0, and we're going to return the visitor. And then in our main method, we're going to initialize the visitor. So visitor t visitor is equal to init visitor, and we're going to pass it in here. I'm going to recompile. We have some errors. So we need to, I forgot to add the visitor here in the visit compound. And I also need to pass it in here. There we go, it compiles. Actually, this one should be, let's just put this as a, to start with, as a void pointer, actually. So, now, when we visit the variable definition, we want to store that variable definition in this list so that we can access it later. So to do that, we're just gonna first check if visitor variable definitions is equal to void pointer, then we need to allocate memory for it. So, oops. Then visitor variable definitions is equal to calloc1 size of struct ast struct pointer. And then what we want to no, actually, and otherwise, if it isn't a void pointer, then we're gonna do visitor variable definitions is equal to reallocate visitor variable definitions visitor variable definitions size times size of struct ast struct pointer, something like that. And then we also want to do, first of all, we want to do visitor variable definitions size plus equals 1. So we increase the size, which we need to do because we're reallocating here to that new size. And then what we want to do is actually, let's put this one inside here, okay? And then after that, we want to do visitor variable definitions visitor variable definition size -1 is equal to node. Right. Cool. And in here we want to do visitor variable definitions 0 is equal to node, and then visitor variable definitions size plus equals 1. So in the case where the list is a null pointer, we're allocating memory for it, and we're putting the variable definition in the first position of the list, and then we increment the size. Otherwise, if the list already exists, we just increment the size, reallocate the memory, and we put our node at the end of the list, basically. And yeah, that's it. Now we can actually just, at the end of this function, we can just return the node. Now let's just see if this, whoa, forgot a 0 here. Let's just see if this compiles and if it runs without errors. It does, cool. So I guess our variable was stored in the memory there. So now we have successfully visited the variable definition, and we're done with the variable definition. So now we're going to go to the next iteration in the loop, and we're probably going to encounter, or I know that we're going to encounter the function call. So now we need to do something about the function call. So we're going to define our built-in print method. So basically what we're going to do is if string compare node function call name. Oh crap. Print. So we're checking if the name of the function the user is trying to call is called print. Then we're gonna do our print method basically. And if it's not, then we're just gonna do undefined method node function call name exit 1, because there are no other methods yet, and you can't define your own methods yet. We haven't added that functionality. Okay, so if the function name is print, then what we're going to do is do our little print thing. So basically, I'm just going to do return built-in function print, and we're going to pass in the node function call arguments. Now we need to define this method, okay? So how do we do that? Well, let's just put it at the top of our file here. So static, we're making this static because it's only for this file. So static built-in function print. Actually, we need to give it the size of the function call arguments as well. So node function call arguments size. Cool. AST takes in a list of arguments, so args, and an int args size. Then we're gonna do for int I is equal to 0. So we're just gonna print all the arguments that we're giving it. So if int I is equal to 0, if I is less than args size, I plus plus. And then we're gonna do ASTT visited AST is equal to visit args I. And now we need to tell it how to print this. So switch visited AST type case AST string. So if it's a string, then we're gonna do printf. We're gonna print a string visited AST string value break. And we don't have any other data types right now, so we're just gonna, if it's not a string, we're just gonna do case. Let's just print the pointer or the address if it's not a string. Visited AST. And then we're gonna return we're just gonna return an init AST and OP, no operation. Cool, so if we implement other data types in the future, we can just add them to this switch here. All right, let's see if it compiles. It does not compile. Too few arguments to function visitor visit. Oh, we forgot to give the visitor visit the visitor. So we actually have to put in the visitor state here as well. So visitor t visitor, and we're gonna give it here. And we need to put that where we call the function as well. So in our visit function call, we're gonna pass in the visitor as well. Still doesn't really work. Return type defaults to int. Oh, we forgot to say that our function should return an AST pointer. And we're getting a warning because it doesn't know what string compare is, so we need to include string.h. Now if we run this, we're getting an undefined method left parentheses. So something is wrong with our parser, I guess. When we parse function call function call name is equal to parser prev token. Right, we need to, in our parse function call, we need to eat the token left parentheses after we store the function call name. So we can do it right after. Recompile. And there we go, we're getting an address. So our print method works, but as you can see in our code, we're actually giving it a variable, and it doesn't know what a variable is yet. So we need to tell it to look for this variable definition. So that's why it's printing an address right now. So in our visitor.c, in the, where are we? In the visit variable, function, we're going to do for int I is equal to 0. If I is less than visitor variable definition size I++, we're basically going to do a lookup for that variable here and return it. So ASTT vardef is equal to visitor variable definitions I. And then we're going to do just a string comparison basically. So if string compare vardef variable definition variable name is equal to node variable name, then we're going to return return visitor visit visitor vardef variable definition value basically. And if we're not finding that variable that the person is looking for, we're going to print an error. So undefined variable node variable name, and then we can just return a node. And yeah, I know we're not going to encounter this return statement, but it's just nice to have it there. Okay, so let's recompile. It compiles perfectly. Now actually I expect our whole program to work, so I expect this to print the undo now. Let's see it. No, it didn't. Why? Visitor should give us an AST string, shouldn't it? Variable definition value. Oh, in our visitor visit string, we're just going to return the node. It's not going to do anything. Okay. Now we recompile and we run it, and now it should print John Doe. It does, but it also prints the address for some reason. Oh, we forgot to return after we have printed, so I'm just going to do return. Recompile everything. Oh, we need to return. Wait, this is weird. Why did I do that? Let's just move this print here, print address, to another thing, another one in here. So default and that should solve it. So I'm going to recompile again, and we're going to run it, and it should only print John Doe. There we go. So our goal, we achieved our goal. Our code is now runnable. So now you can actually define more stuff in there. Oh yeah, we have our source code actually hard coded into here. So, but now you can actually do. We should probably make it so that we read the file from disk instead of having it hard coded here, so that we're actually reading this file. But now you can actually do more stuff here. So you can do var other name is equal to Sarah. And maybe you want to print that as well. So let's just print both names. So print name, print other name. Cool. So that's it, guys. If this video gets enough likes and attention, I will make more parts to this series where we actually add some other data types and make it possible to define your own functions and function scopes and stuff like that. But yeah, we achieved the goal that we wanted to do, that we wanted to achieve in this series. And I hope I was able to make you guys understand a little bit of how this works. So yeah, thank you so much for watching. Everything works as expected. Let me just go through the visitor real quick here to just brief it a little bit. So we are creating a lexer, which is creating tokens from this source code here. We're giving the lexer to the parser. The parser gets tokens from the lexer, and it creates an abstract syntax tree that is like recursive. And we call that the root node. We're getting the root node here. And then we're creating a visitor, and we're calling the visitor visit, and we're passing that root node into that function. And then the visitor knows what to do with each AST node type. So this is the function that's being called, and this function is the main entry point for the visitor. And this one just knows which function is appropriate to handle the node that is passed in. So if it's a variable definition, it calls the variable definition function, which currently just allocates some memory for that variable definition and adds it to a list so that you can access it later. And if we're visiting a variable, we're calling the visit variable function. And here we're just performing a lookup for that variable and return it. And then we have the function call, and then we're just visiting the function call. And here we have a built-in method that it's being called if the name of the function call is print. We're calling for our built-in print method basically. And if we are counting a string, we just return the node. There's nothing to do with it. And if we're encountering a compound, we're just iterating through the compound size and visiting all the children. And if we're encountering a AST new operation, we just return the new operation break, and that's it. Thank you so much for watching, guys. And yeah, like this video if you want another part. So yeah, if it doesn't get enough attention, I think this will be it for the series. But if you really want to see more, and if you really want to if you really want me to show you how to define your own functions, be able to define your own functions and stuff like that, I will continue the series for you guys, okay? So yeah, thank you so much for watching, and I'll see you in the next video.